here we go. We'll try. I think this is correct, but number one, the first type of factoring. Well, factoring is the opposite of foiling. So foiling, you're making something bigger. Factoring, you're breaking something down. So if I say, what are the factors in high school dropouts rates? There are multiple factors. You would take the problem, which is high school dropout, and you would break it down to smaller things. And that's what factoring is in math. You're going to be given a bigger problem. You're going to break it down into smaller things. There are, I think, 5 types of factoring on this sheet. And I'm going to go through them with you, starting with the first. The first is factoring out the GCF. What does GCF stand for? Greatest common factor. If you do not know that, write it down. But GCF stands for the greatest common factor. And this is an example of why I'm going to record this lesson. Because if you go to your tutor and you say, well, my teacher said take it out, put it out, and bring the leftovers down, your tutor's going to be like, what? Your teacher said what? Because these are just little tricks that I made up. So that's why I want to record these. We'll try to put them on Moodle, so if you don't remember this, you can go back and you can show your tutor, yes, here's what she said. This is her saying it. But this is very important. If the problem starts with a negative, you must take out a negative. Now, that's true your whole life. It doesn't matter what type of problem we're doing. If a problem starts with a negative, you want to take that out first. So let's do 2 examples. I'm going to start with an easy one. So let's do 24a cubed b squared minus 15ab plus 6a to the 4th b to the 3rd. We'll just say that. This is a trinomial. That was a question that Nathan asked. How do you know kind of what you're dealing with? This has addition and subtraction, and it has 3 terms, so it's a trinomial. The first thing you want to do is you want to decide what the GCF is. Now, I'm going to actually write it out over here. So let's decide what the greatest common factor is. And the first thing you do is you look at your numbers, your coefficients, 24, 15, and 6. What is the largest factor that will divide into those 3 numbers? 3. So my GCF is going to have a 3. And then I look at my A's. I always relate this to children, or apples. Let's do apples. If this person has 3 apples, and this person has 1 apple, and this person has 4 apples. So somebody's got 3 apples, somebody's only got 1 apple, and this other little kid's got 4. How many apples do they have in common? In other words, they all share the experience of having how many apples? 1. So it's just A1, because that's all they have in common. So that's my greatest common factor. And the same thing for the B's. 2 bananas for this kid, 1 banana for this kid, and 3 bananas for that kid. They only have in common 1 banana. They don't all have 2 bananas. They don't all have 3 bananas. Nobody's got 4 bananas. So they share 1 banana. So my GCF is 3a to the 1, b to the 1. Now, that's just work for me to write over to the side. Now I'm going to start my steps. Step number 1 is you take it out. What is it? Well, it is the GCF. So we're going to take out 3ab from every single term. This is rule number 1, is to take it out. You take it out of the polynomial. In order to have a GCF, it has to at least have 2 terms. I better not. I don't know if it'll record me if I walk around, so I better stay over here. So you can only have a GCF with 2 or more. There's no GCF for a monomial. All right, so rule number 1, reach paper, take it out. That's what I just did. Number 2, put it out. What you just took out, which was a 3ab, you're going to put it outside of a parentheses over here. So put yourself, and this is going to be the final answer. We're almost done. We only got one more step. I'll go ahead and put a box around it because this is going to be my answer. So you take it out. That's your first step. Number 2, you put it out. What do I mean by that? Put it outside of the parentheses. You don't just fluff it away. Now, sometimes things disintegrate, but not this. This is the greatest common factor. You pull it out, you put it in the front. And then number 3, you bring the leftovers down. Now, this is why last week we studied monomials, because we're getting ready to have to simplify these 3 monomials. So, 24 divided by 3, your whole entire life has been what? 8. All right, and then you look at your A's. You have 3 A's on the top and 1 A on the bottom. This is what we did last week, so this is good review. Where are there more A's? Top by 2. So it'll be A squared. And you do the same thing with your B's, and you just go all the way down. All right, B2 and B1, there's 1 more B on the top, so it'll be B. So what we're doing now is we're just simplifying 3 monomials. We already did this for 2 days last week. All right, 15 divided by 3 is going to be a 5, and it's a subtracted. All right, if you have an A1 on the top and an A1 on the bottom, what are they going to do? Cancel. Same thing for your B's. So the only thing left there is a 5. And then we'll do the last one. There's a plus sign, so I'll put a plus 2. 4 A's on the top and 1 A on the bottom. That's going to leave me with A cubed on the top. 3 B's on the top, 1 B on the bottom. That's going to leave me with B squared. And that's it. That's the final answer. You cannot combine any of those things in the parentheses because they're not like terms. So that is the final answer for taking out the GCF. Okay, I'm going to do one more, and this time I'm going to have a negative in front of it, because if you look at this rule right here, if it starts with a negative, you must take out that negative. So let's do one more. I'm going to squeeze it up here. My things roll around. Let's do negative 39 x to the 4th y squared z minus, or let's do plus 18 x y to the 5th z to the 3rd. This is a greatest common factor problem. Now, Nathan asked a good question earlier. He said he was getting kind of confused when everything scrambled up on the sheet of paper. Well, you just wait till about an hour from now when we scramble up all the different factoring types on the same sheet of paper, and I don't tell you which technique it is. So you have to look at it and decide if it's GCF or difference of perfect squares or whatever. All right, very, very, very important rule. If you ignore this, it's just going to be wrong. But if a problem starts with a negative, okay, in other words, this leads off with a negative, then I'm going to have to take out some kind of negative. If it's nothing but a -1, I'm going to have to take that negative out. So the first thing I want to do is I want to go over here and just decide what my GCF is. I'm going to write small. What will go into 39 and 18? 3. And it has to be a negative. So we're going to take out a -3. And then we just go through our x's, okay? If this guy has 4 x's and this guy has 1 x, how many x's do they share? 1. They share 1 x. So x, 1. All right. 2 here and 5 there. So how many do they share? 2. And this one has 1 z and that one has 3 z's. So they just share 1 z. Now, that is the GCF. That's not the answer to the question, but I like to write the GCF over to the side just to keep my mind straight as to what's going on. All right, then we will follow our rules. Number 1, take it out. So I'm going to take out a -3 xy squared z and a -3 xy squared z. I take it out of both of the terms. If there's 2 terms, you take it out twice, 3 terms, 4 terms, 6 terms. You can do this for an infinite number of terms. Rule number 2 is to put that outside of the parentheses, and this will be your answer. So I'm already ready to write my box for my answer. But this negative 3xy squared z has to be put outside of parentheses. That's what I mean by put it out. Put it outside of parentheses. It does not vanish. Now, later today, we will find something that does vanish, and you just completely obliterate it, but not here. The GCF goes out in front. Now, watch your signs here. A negative divided by a negative is a positive, and that's going to be a 13. I'm going to be left with x cubed. My y's and z's cancel, I think, if I did that right. Y'all agree with me? Okay. And then again, watch your signs on the next one. You have a positive 18 divided by a negative 3, so that's a negative 6. My x's cancel. I'm left with y cubed z squared. Now, that is our first type of factoring. We don't use that a whole lot in and of itself. Most of the time, if you have a problem that has a GCF, it has another type of factoring to go along with it. So it would be like GCF and a trinomial, or GCF and a grouping, or something like that. But GCF is not something we use a whole lot. All right, moving on. Number 2. We're going to take our notes and then we're going to practice. Factor by grouping. We're only going to do one of these. This is by far the least important type of factoring. By far. But grouping works when you have an even number of terms, 4 or more. So multiples of 2, 4 and up. 4, 6, 8, 10. All of those would work for grouping. So we're just going to practice one. Let's squeeze it right here. All right, so we'll have a cubed plus ab minus a squared b minus b squared. This is another example that if you take this to your tutor or you ask your girlfriend to look at it or whatever, and you tell her, well, my teacher told me take it out once, cross it out twice, they're going to say, I don't know what she's talking about, okay? A lot of the stuff that happens in here is stuff through the years. I've been teaching pre-calculus and factoring for 17 years. It's just stuff, little tricks that I made up on my own, but it's not going to be in a textbook, okay? All right, so number 1, what you do is you group. How do you group? Well, you group it the same way every time. You group the first 2, and you group the last 2, but you make sure you take this sign in the parentheses. So in other words, everything has to fall into a group. You can't leave anything hanging out. It either has to be in the first set of parentheses, which is your first 2 terms, or it has to be in the second set of parentheses, which is your last 2 terms. And you can't leave that sign hanging in the middle. It happens to be a subtraction for this particular problem. So number 1, you just group. You're not going to have the parentheses on your paper. You're going to have to add them yourself. Oops, sorry. Number 2, you're going to GCF it twice. Well, we just learned how to GCF, so we're going to do GCF twice. Let's just do this one first. What is the GCF of a cubed and ab? A. That is correct. So we're going to take it out. Take out your a. Take out your a. We're going to put it out, so put it out there. And then we're going to bring our leftovers down. So a cubed divided by a leaves me with a squared. And ab divided by a just leaves me with b. So I did GCF on, this is a parentheses, on the first set of parentheses. All right, I'm going to put my hand over that one, and we'll do GCF on the second set of parentheses. Now, we just learned if it starts with a negative, we got to take out some kind of negative. So I know, oops, I just made a mistake. It's not a. What do a squared b and b squared have in common? b. So it's going to be a negative b. The only thing that we can take out of this is a negative b. What are your rules? Take it out, put it out, bring your leftovers down. So take out your negative b, and then bring down what's left over. A negative divided by negative is going to be a positive a squared. A negative divided by a negative is going to leave me with a plus b.
What happened to the exponent on B?
Right here?
Yeah.
If you've got 2 on the top and 1 on the bottom, you're going to be left with 1 on the top because one of them is going to cancel. 2 subtract 1 is 1. Is that where you're talking about, right there?
You don't make it a B cube?
No, you subtract. Remember the rules from last week.
Yeah.
If you're asked to divide, you're actually going to subtract those exponents. So 2 subtract 1 is 1. That's why it canceled here. 1 subtract 1 is 0, so there were no b's left there. When you're dividing, you subtract the exponents. Same thing here. 3 subtract 1 left me with a squared. Now, this is how you know that you're right. We're not finished yet, but I know that I'm right here because if you look at these parentheses, they are exactly the same. This one says a squared plus b, and this one says a squared plus b. If you do factor by grouping and your parentheses are not identical, same order, same sign, same powers, then something's not right. But if you do this and the parentheses match, you're not finished, but you're going to be correct. So here's where my little rules come in. Number 1, take it out once. Well, this is what I mean. Take this out one time, a squared plus b. Take it out one time. You're basically doing GCF again. They have in common an a squared plus b. That's what both terms share. So you're going to take it out one time. I just did that. You're going to cross it out twice. So cross it out 2 times. Once, twice. Cross it out twice. I don't want to cross it too much because then you won't be able to see what I'm. And then the last step is that you bring the leftovers down. So leftover here is an A, and leftover here is a subtract B, and it has to go in that order. So it has to be A subtract B. Those are your leftovers. And that is the answer to that question. Yep. All right, let me show you the connection between factoring and what we did on Thursday. Okay, so let me show you how this works. If you take this answer right here, I'm going to write it on my note card. A squared plus B, and then A subtract B. Okay, so I'm going to write that on there. That was my answer. I'm going to FOIL it out, or you can do the box method. So let's do FOIL. So let's FOIL this out. First, outer, inner, last. A2 times A1 is A cubed. The outers would be minus A squared B. The inners would be AB, and the last would be minus B squared. None of these are like terms, so I can't combine anything. And you don't have to write this down, but what you're going to end up with is where you started. So let's look at where we started. All right, I just FOILed it, and I got the answer that I started with. So FOILing undoes factoring, and factoring undoes FOILing. So when I FOILed it, I had an A cubed. Yep, there's the A cubed. I had a subtract A squared B. Yep, there's the subtract A squared B. I had a plus AB. Yep, there it is. And a subtract B squared. There it is. So factoring can be checked by FOILing. FOILing can be checked by factoring. So if you get on the test or the quiz, and we'll talk about this more, and you're not sure, you're like, I don't know if that's supposed to, I'm not sure if that's right. Foil it out. If you get your original problem, you're correct. If you don't, you're not. So foiling and factoring undo each other. All right, let's do the next type. This is my favorite type in the history of life. And then we'll practice. Okay, I'll give you some to practice. This is called the difference of perfect squares. Now, that's the math word for it. It's called the difference of perfect squares. And when you go on to wherever you go after me, you tell your teacher that. Or you go to your tutor, you say we learned difference of perfect squares. But on the down low between us in this classroom, not outside these walls, I call it the breakup story. I love it. I love this. Tyler, you ever had a breakup? No. No? Okay. Anybody ever experienced a breakup? Me and Kayla. Okay. Well, me too. I've had a breakup. And if you've ever had one, you'll understand this story. All right, so let's practice. I got to do a math problem and explain the story at one time. All right, so here's the first problem. 4x squared minus 25. Now, this is going to be great. You're going to go home. If this records correctly and this works out and it picks up my voice, you're going to go and be playing this for your family, your siblings, your roommates, and let them listen to this because this is genius. All right, first of all, it's two people. Okay, two terms. The difference of perfect squares only works for two terms. I'm not writing all this down. I'm going to tell it to you because if you pay attention, you'll be like, yep, that makes sense. So we're talking about two people in a relationship. And the people are having their differences. What does it mean if you and your girlfriend or boyfriend or husband or wife are having differences?
You're not agreeing.
You're what?
Not agreeing.
Right, you're not agreeing, right? There's something that you're not agreeing on. You're having some differences. So y'all decide that you need to break up. Now remember, it's two people. This doesn't work for three. It only works for a binomial. So you're having your differences. Now, this right here, this subtraction sign, means you're having differences, okay? So I'm going to put a little sad face right here. These people are having their differences. And they decide to break up. Well, what's going to happen is 4x squared is going to split, okay? So half of the heart's going to be over here, and the other half of the heart's going to be over there. And 25 is also going to split because when they break up, they're going to break up. This is a broken heart split up. Now, if you were to take the math term 4x squared and split it into two perfectly symmetrical parts. They got to be exactly the same, but you got to split it. What would be in each part? 2x, 2x. Very good. So this is going to split up to 2x and 2x. Same thing for 25. This is going to split up to 5 and 5. Now, I'm going to go back to the math explanation after I finish my story, but they have to be perfect squares. I'm going to give you a sheet today that lists a lot of perfect squares if you're not familiar with them, but perfect squares are numbers that you get when you square something. That's what a perfect square is. Okay? Now, back to my story. Okay, let's recap. These people are having their differences. I put a sad face for their subtraction. They're having differences. They decide to break up. So this one has to split its little heart straight down the middle, and this one has to split its little heart straight down the middle. And then we're ready for our answer. When they break up, we're going to have two sets of parentheses, because when they break up from this relationship, they have two types of feelings towards each other. What do you think they are? Sad or happy. They have, okay, so put 2x in the front of both parentheses because that's what came first. We have to follow our order. 2x was first, so 2x has to go in the front. 5 was at the back, so 5 has to go at the back. And like Tyler said, when these people break up, there's going to be two types of feelings that they're left with. Some of it is going to be happy. Tyler, why would they be happy? Why do you think? Stress-free. That's a good one. No drama. The experience, yeah. Okay, and they're also going to have a little bit of sadness. Now, let me go back and finish my pictures. So this, they're going to have a little bit of, a little bit of happiness over that relationship, and they're going to have a little bit of sadness. Why would they have sadness over, there's a lot of reasons, but why? Very good. That's exactly right. Okay? Now, that is a combination of a real-world story and a mathematical concept. But let's go to the math for just a minute. All right, the first word is differences. This only works if it is a subtraction. It does not work, and I'll show you that in just a minute. It does not work for an addition problem. And it only works for perfect squares. Now, let's list out some perfect squares. Just start naming some. 4, 9, 16, 25, 100, 144. I've got a sheet that's got these listed, but a perfect square is the answer you get when you square a number. That's what a perfect square is. I've got this on a sheet. 144 is 12 times 12, so that's a perfect square. This only works for binomials, because if you go back to my breakup story, it's 2 people, because if there was 3, there was problems to begin with. Okay, so this is a difference of perfect squares, only works for 2 people. Now, let's go over here. What about this one? Let's do 16x squared plus 49. This is a good one. All right, we have 2 people. They are perfect squares. If you think about 16x squared, that would split to 4x, 4x. Now, what it does not split to is 4, 4x, x. That's wrong. Matthew.
Yeah, I'm good. Okay.
What happened?
I just slipped back from the clear.
Did you hit your head on the table?
No.
Okay. This is 4x, 4x. It's not 4, 4xx. That is not correct. It's 2 things. Think about a heart splitting down the middle. You get a left-hand side and a right-hand side. You don't get 4 sides. Same thing here. 49 is 7 times 7. But, go back to my story. This is called the difference of perfect squares. Are these people having differences? No. Robert's shaking his head no. These people are happy. They're not having any differences. Everything is going beautiful for them. They are not going to break up. Now, what do we say if we cannot factor a problem? This cannot be factored. I can't do GCF. I can't do grouping. I can't do difference of perfect squares. I can't do anything here. So what is my answer? It's a word. It's an English word. 5-letter English word. If something cannot be factored, 7 is this type of number. 3 is this type of number. 13, prime. That's right. This is prime. If you have a problem and you're supposed to factor it and it cannot be factored, you say prime. Now, later we're going to do this worksheet right here. And it's going to say, if it cannot be factored right, not factorable. I prefer the word prime. Is shorter and it is more mathematical than not factorable. Okay, let's see if I am smart enough to pause my video.